Have you ever wondered how we can measure things we can't even see? Like the exact amount of sugar in your juice or the purity of life-saving medicine? Well, it all starts with a simple trick of the light, one that you've definitely seen before. Right? You've seen this a million times. You stick a perfectly straight straw in a glass of water, look at it from the side, and bam! It looks like it's bent, or even completely snapped in half right where it hits the water. So what is going on here? Well, that little visual glitch, that's not your eyes playing tricks on you. It's actually a really important clue. It's like a breadcrumb that physics leaves for us, leading to an incredibly powerful way of seeing the invisible world all around us. So, this trick has a name, of course. It's called refraction. And all it is light changing its path when it moves from one thing, like air, into another, like water. See, light actually slows down a bit when it hits the water, and that causes it to bend. That bend is what creates the whole broken straw illusion. Okay, now here is where it gets really, really cool. That bending of light, it's not random. It's predictable, it's measurable, and it turns out it's like a secret signature for pretty much any transparent substance out there. We call that signature the refractive index, or RI for short. The best way to think about it is like a fingerprint. Your fingerprint is unique to you, right? Well, a substance's refractive index is unique to it. It's a specific number that tells you exactly how much that material bends light. And check out how sensitive this is. Pure water bends light a certain amount, but if you dissolve some sugar into it, the light bends even more. Why? Well, because now you've got all these sugar molecules getting in the way, kind of like a traffic jam for light, slowing it down just a tiny bit more. The signature has changed. So, here's the big idea. If we can measure that tiny, tiny change in the bend with incredible precision, we can figure it out exactly how much sugar is in that water. No tasting, no complicated chemical tests, just by looking at light. It's an amazing concept, but how do we actually do it? We do it with this awesome piece of tech called a digital refractometer. You can think of it as our light decoder. It is purpose-built to do just one thing and do it perfectly. Read light's secret signature. Now, this machine uses a super clever bit of physics. Instead of just measuring how much the light bends, it finds the exact angle. And this is the key part. It's called the critical angle, where the light stops going through the liquid at all and just reflects back completely, like a perfect mirror. That specific angle is directly tied to the refractive index. And the whole process is so simple. You just put a single drop of your liquid onto a special prism. A little light, an LED, shines up at it. A tiny sensor, kind of like a camera, finds that exact angle where the light perfectly reflects. And boom, a tiny computer inside does the math instantly and gives you that all-important refractive index. Okay, so the machine spits out a number. Great. But a number by itself doesn't mean anything, right? How does that tell us how much sugar is in our juice? We have to turn that raw measurement into actual meaning. And to do that, we need a map. Just think about it. If you're trying to find an unknown address, you need a map of known streets to get your bearings. It's the exact same idea here. To figure out the sugar in an unknown sample, you first have to build a map using samples where you know the exact amount of sugar. In the science world, we call this a standard curve. So what you do is make up some known solutions, a 1% sugar solution, a 2%, 3%, and so on, and you measure the RI for each one. And look at this data. You see that? It's a perfect, predictable pattern. As the sugar goes up, the refractive index goes up right along with it, in a beautiful straight line. And because it's a straight line, we can describe it with a simple equation that you probably remember from math class, y equals mx plus c. Now this isn't just some boring old formula. It is our map. This equation turns all those individual data points into one powerful tool. So using the map is as easy as 1, 2, 3. First, you measure your unknown juice. That number is your y value. Second, you just plug that number into your map's equation. And third, you solve for x. And just like that, the math tells you the exact sugar concentration. It's that simple. Okay, so this is a really neat lab trick, but why should you care about any of this? Well, it turns out this whole process of decoding light's signature has a huge impact on our daily lives, from the science lab all the way to your lunchbox. Every time you pick up a bottle of juice and see the sugar content on the label, that number was almost definitely found using a refractometer. They use this to check the quality of honey, to make sure syrups are just right, and even to help farmers know the perfect time to pick fruits and veggies based on their sugar levels. And speaking of farming, this is absolutely essential for making wine. Winemakers will actually go out into the vineyard with a portable refractometer, take a tiny drop of juice from a grape, and measure its sugar right there on the spot. That one number tells them if it's the perfect time to harvest. And this gets even more serious in the medical field. This technique is used for quality control on liquid medicines to make sure every dose is exactly right. It's even used to analyze urine, where a tiny change in its signature can be an early warning sign for things like dehydration or even diabetes. And the reason it's trusted in all these really important fields comes down to this number. The accuracy is often plus or minus 0.00001. I mean, that is an insane level of precision. It's so reliable, you can stake a multi-million-dollar business or even a patient's health on it. So let's bring it all back home. That simple, everyday illusion of a broken straw in a glass, it's not a glitch. It's a window into the physics of light. It's a clue that led us to build these incredible tools that see the invisible for us, and they impact our world in countless ways every single day. Which leaves us with one last thought to chew on. We've seen how light can reveal the hidden signature of sugar dissolved in water. If it can do that, what other invisible secrets, what other hidden things all around us is light just waiting to help us see?